Welcome, folks, to Safety Connection, Burning Questions, Managing Flammable and Combustible Liquids. I'm Tova Larson. Like I said, I started my career as a laboratory chemist and became a health and safety professional when I crushed my right foot working in a welding shop. So that's how I got into safety. It's why I love what I do. And we are going to launch right into the Ministry of Labor, Immigration, Training, and Skills Development Demographics Collection Survey. Just so we're all clear, this is not a survey of like your personal details. This is more to get a sense of who's using the services of the safety associations. It's to get a sense of how we can better meet your needs. So if you would kindly click on that link, the function number is why is this transcribing into the chat? I don't want transcription. Jim, how do I make this stop? Okay, we're gonna stop. This is my first time recording, doing the record on my own, and this started recording to the cloud. Okay, I think the transcription stopped. I don't know if you could see it. I could see it, and it was absolutely driving me up the wall. Nobody wants to see themselves talking. So the demographic survey, the function number is on the screen. I'm also going to put the link into the chat. And we're going to go ahead and get started. Okay, so onward and upward. To use your Teams room, if you're not familiar with Teams, computer audio obviously is recommended. We do have, what was the number again? It was 229-278. Action number is 229-278. And this is the link here for the demographics survey. You know, one of the big things that we want to make sure that we're meeting our folks, meeting our members where they're at. The more we know about you, the better we can be as a safety association. And we are a safety association. That means that we are funded through WS Labor premiums to serve our member sectors. That means we need to be responsive to the needs of our members. What do you need? We want to be here for you. So there you go. Drop that into the chat. Computer audio is recommended. This is also a meeting where your microphone and your camera will remain muted and off. All the interactions are going to come through the chat, so we're going to go ahead and do that. We also have some engagement features. There's reactions. If I say something funny or you're like, what? Feel free to do that. We also have, we're not going to be using polls here. I just have chat questions. The meeting chat, you click on the speech bubble, opens up a little window on the side. You can type your message into it. Hi, Bill. He's in the chat. You can go ahead and type your questions. I take questions through the entire session. So if you're like holding your questions to the end, don't bother. You may as well ask them as we come in. I monitor the chat as we go. And we also have some accessibility features for you. You can turn on the captions, which I did, and then turn them off. But if you want the captions, go ahead and turn the captions on. They are computer generated, so like on the accuracy, but they're pretty good. And you can also make the screen full screen by clicking the view option. And you can make it big. Am I sharing the presentation? We cannot share presentations. Because the images are all copyrighted, and we have, through our license agreement, we're not actually able to transmit those images. So as a result, we do not share our presentations. But if you would like to share, once the recording is posted, you're welcome to share the recording with absolutely everyone who you think this session would bring value to. And so what is a Safety Connection? You may be new to Safety Connection. Safety Connections are no-cost information sessions. It's not training, but they've got a lot of really good stuff here. in our wonderful world of Safety Connection. I like to think of them as the best unsung hero of WSPS. They are a great opportunity to share, learn, and discover what's of value to you. We may be talking about like aerosols, and you may not work with those. You may be, you may be working with, something that you're like, oh, maybe this doesn't really apply to me. That's totally fine. It's about picking out the nuggets of gold that really apply to you. Obviously, you're attending from your personal workspace. We've got some like question and answer for you, and also an opportunity for you just to pick the brain of a health and safety professional, which in and of itself is kind of a valuable thing, and to connect with industry peers. So it's also really interesting. I think about the big picture of Safety Connection. Use your raise hand tool. It's like the little raise. If this is your very first Safety Connection, if you've never attended a Safety Connection session before, just use the raise hand. I would love to know if there are folks and you're like, this is my very first one. You have just stumbled. If you're about to click that hand, you've just stumbled on one of the greatest unsung heroes of the health and safety system here in the province of Ontario. Shameless plug for some of the other sessions that I have coming. Managing young workers, what every supervisor needs to know. Shameless plug. It is an incredible session. We have sessions on, I have one that's in development on how to learn to read and use the Green Book. Just the basics of like, okay, let's figure out how to find stuff in this and make that doorstop shaped book a really valuable tool for you. We have sessions on consensus and committees and, ooh, yeah, right? And they're all no cost. So if this is your very first one, I would really encourage you to take a look at the Safety Connection catalog, and go from there. Okay. Ooh, that's a super technical question, John. I love it. That is a great burning question. All right, we're going to move, and I'm going to hold that one to the end. We're going to go ahead and head right into our session. Welcome to Burning Questions, Managing Flammable and Combustible Liquids. I'm Tova, I'm a chemist, and we're going to launch right in. So what are we going to be doing here today? We're going to be talking first about some administrative labor, immigration training, and skills development, occupational hygiene campaigns. Why are we even talking about this right now? And by the way, for those of you that are maybe listening to this in the future, today is March 4th of 2025. And why are we talking about this right now? We're going to discuss some of the hygiene campaigns. We're going to talk about some preventable tragedies that involved flammable and combustible liquids, to get a picture of what the problem here is. And we are going to then talk about understanding fire and then understand how we're going to control these flammable liquid risks. So first, let's talk a little bit about the occupational hygiene campaigns 2024, 2025, and beyond. We do have some new changes to the hazardous products regulations, and worker exposures to chemical agents in the workplace are a perpetual problem. And so the ministry is focused in on a two-phase approach. Between April 1st of 2024 and March 31st of 2025, the MLITSD reached out. They're, focusing on education and outreach with a campaign promotion to various stakeholders, so agency groups, associations like us, to really try to get the word out there that the ministry has a laser focus right now on the occupational hygiene side of our risk picture, because we've had some changes to the hazardous products regulation. And I'm going to be really honest with all of you about how this session even started. So how did we end up with a session of flammable liquids? I saw a really sharp rise in the number of questions that I was getting, and folks that were in what can best be described as panic mode. They'd received visits from the ministry. They'd received orders with regard to flammable liquids, and they didn't know what to do next. So it was a great example of, the fact that there is a focus on this. And the kinds of questions I was getting and the kinds of things that I see in workplaces when I visit them tell me that this is a pain point for a lot of workplaces. I mean, I also had a customer, it was a couple of years ago, who said, I'm soaking rags in like ethanol. I'm wiping a red hot heated knife with it. We've had 12 fires and I can't figure out what's going on. And I thought, I think we need some help here. So that's how the session started, the kind of idea development. And the ministry obviously has a laser focus on this. Now, phase 2 is going to be the enforcement piece. That's the piece where they are going in proactively into workplaces where this may be a concern, and they are going to be issuing orders. So do know that enforcement, it is coming. I mean, it's already here, but it's definitely coming. There is a WHMIS campaign on right now around Regulation 860. Employers obviously have a duty to provide workers with information on hazardous materials, and the information is largely delivered through those 3 pieces of the WHMIS program: labels, safety data sheets, and the worker education, which is not just a click-through training, click, click, click. It's also the hands-on worker aspect as well, so that product-specific, site-specific, usually delivered by a qualified and competent supervisor type training in the workplace. And you got to have both. And changes to our workplace labels and safety data sheets will require employers to go and update their training, including the product and site-specific elements, because we are now looking at changes to things like classification. In terms of the rationale for this campaign, we did see federal legislation, federal regulations change. It required suppliers to make some changes to, so these are some great questions that are popping up. The HPR was amended in December of 2022 to include changes to hazardous classifications. There is a 3-year transition period right now, ending December 31st of December of 2025. This will require retraining on WHMIS, and a lot of folks don't know that. Now, how often, by the way, and this is a question in the chat. So my question to you is around training. How often do you actually have to train people on WHMIS? Now, interesting. All right, so the answer is, under Section 42 of the OHSA, and I'm going to speak to OHSA here, is that you have to provide training to workers on chemical and hazardous chemical and physical agents. You have to review the training at least annually, or more often if required. It is all of this is done in consultation with the Joint Health and Safety Committee, of course. But one of the important things to remember is that review doesn't necessarily mean retrain. You could send a survey monkey around, and if people fail your survey monkey quiz, then they have to take the training again. It's not necessarily specified. However, doing it annually is definitely recommended. And anytime, as Jane points out, and there were a couple of other folks that said, anytime that there's an updated safety data sheet, you also then need to retrain on that product because there's new information. So when we think about the big picture, there's a lot of different ways that this can look, but you need to make sure that you are training. You will need to retrain everyone no matter what, because there have been some changes to the program, and folks need to know this. So what are the hygienists focusing on? They are currently focusing on proactive inspections to ensure compliance with the WHMIS regulation. They are, in fact, looking to see, have you received products that now have safety data sheets with some of these new classifications? What triggers the need, that cascade of training? Once you get a product and a safety data sheet that has these amendments to them, that's the point where you need to retrain on that product. Ultimately, the goal is always to prevent injuries, but also exposures. And we're going to talk about fire as more of a physical safety problem rather than occupational disease. But remember, many of the products that we're going to be discussing here also have massive disease problems. So things like cancer, things like occupational dermatitis from defatting of the skin, those are all things that happen with many of these flammable products. It's not just, hey, I'm flammable. It's like, I'm flammable and I have like 8 other hazards associated with me. So be mindful of that too. So what are some key changes to the hazardous products regulation? There was a new physical hazard class adopted, chemicals under pressure. And we're going to talk about aerosol cans because they're chemicals under pressure. There was a new hazard class name change for flammable aerosols. Again, talking about those aerosols. Sometimes we forget that, like, oh, I've just got a little can of WD-40. You've got flammable propellant. Even if the contents are just combustible, once you add a flammable propellant and you start spraying it, you're adding air, the risk goes up. There's a new category that's been adopted for category aerosols category 3, non-flammable but aerosol products. There are new subcategories for flammable gases. They did repeal the pyrophoric gases hazard class. And these are now categorized under the flammable gases category 1A. And products that are classified under combustible dust, there's now a second hazard statement option that says that they may form explosive dust-air mixtures. And we're not going to talk a lot about dust-air mixtures. Obviously, our focus here is on flammable liquids. But it's worth mentioning if you are dealing with dust-air flammable mixture issues, that may be something that you need to pay attention to. And they're absolutely devastating when they do happen. Other key changes are changes to Section 3 around composition. They are using narrower concentration ranges that fall with one of the prescribed concentration ranges. So the range allowed is getting smaller. As I said, it's like 5 to 50%. You're like, really? That's a really wide range. You're not going to see as much of that. All the hazardous ingredients in a mixture at concentrations above the cutoffs also have to be disclosed. Again, that's a bit of a change. And suppliers are required to provide, obtain, or prepare written documents that must include changes to the safety data sheets and the labels that are required as a result of significant new data. And when we talk about significant new data, all of this is considered significant new data. There are also some key changes to Section 9, which is all about physical and chemical properties. It's one of my favorite sections to review. And the new thing that you're going to see is particle characteristics. This is also a great tip to see if you have an updated SDF. If you see even if it says no data available, it has to be there. So if you want to know, is this an old safety data sheet or a new safety data sheet? Look in Section 9 for particle characteristics. If it's there, then you have a new sheet. It's also one of the ways the ministry inspectors are also checking to see if it's a new sheet, is they look for particle characteristics. If you are writing down notes, write this one down. It is a like, we've got burning questions, hot tips. I was full of puns on this one. Regulation 833, we can't forget about these exposures. There is still a campaign focused on this because occupational disease is the leading cause of worker death in the province of Ontario. Every year, there are 4 times more deaths from disease than there are from traumatic fatalities. And so the ministry does put a significant focus on protecting workers from these types of exposures. When we think about, assessing and controlling exposures, this really does help reduce the risk of workers developing long-term disease. So there is a campaign. My apologies, I keep touching my nose. I have 3 cats, and I think I have a cat hair, like, right underneath my glasses, and it is driving me up the wall. Campaign focus. Ministry of Labor, Immigration, Training, and Skills Development will be conducting proactive inspections along with the Reg 860 campaign. They are focused on a Reg 833 campaign. And the goal is, of course, to ensure that workers are not being exposed to hazardous substances exceeding the occupational exposure limits. Their focus is going to involve assessing worker exposures They're going to be looking at your procedures. They're going to be observing your work practices, evaluating your control measures, and reviewing your exposure data. So if you do have occupational hygiene testing that's been done in your workplace, be sure that you have those records available. They may even require air sampling for certain chemical agents to ensure that workers are in fact being well protected. So let's move into talking about our flammable liquids tragedies, and these are absolutely devastating. The first that we're going to talk about comes in 1994, and this involved a worker named Sean Kells who suffered third-degree burns to 95% of his body. Sean was 19 years old when he died. It was his third day on the job, and his father actually became a passionate advocate for workplace safety as a result of his death. This is a scenario where he was dispensing a toluene product from an unmarked drum, so no information provided to the worker. He was decanting it into a smaller container. And when we think about dispensing or decanting, this is a high-risk activity. This is where so many of these exposures, in fact, do happen. And in this case, there was a static discharge that ignited flammable vapors that then flashed back into the drum, causing it to explode, engulfing the worker in flames. When we look at some of the contributing factors that led to this incident, one of them was that there was no bonding or grinding to dissipate the static energy. Static, when we think about static, people picture like feet on a carpet, but when we think about static with flammable liquids, the static can actually happen within the liquid itself. And when we talk about flammable liquids, there are polar and non-polar. Polar liquids are things like, and water is an example of a polar liquid, but there are, of course, flammable liquids that are polar. They, in fact, due to the electrochemical nature of the molecules themselves, do a better job of being able to transfer static electricity within the liquid, but it also means that it's easier for that static to leave the liquid. When we get into more non-polar products, they don't do as good a job of being able to transmit electricity, and as a result, static can actually build up in the liquid itself. It can happen where you've got the flow of a non-polar liquid, just even flowing along a pipe or along a container. When you think about that's flow, that's where static can come from. You can get internal static in the liquid as well. And without an adequate plan on how to manage static in particular, you can have static discharge. And in this case, it was a static discharge. The worker also had absolutely no training. They had no awareness. They didn't have information about the product. I'm not even sure that the individual knew the product was flammable because it didn't even have a label on it. Add to this, young, brand new to the job, hired by his dad's friend. We're talking level of risk jack to the max in terms of the internal responsibility pieces that were not followed here, and a worker who really was unaware of the risk. This was many years ago, so the fines look really small, and at the time the fines were quite a bit lower, but the company was fined $75,000. The owner was fined $10,000. And a 19-year-old young man with his life ahead of him lost his life. It's a devastating, devastating tragedy. Mother Teresa High School in Ottawa, where I'm from. In fact, 2 of the 3 case studies here are from Ottawa. Mother Teresa High School, this was a shop class making barbecues out of steel drums. They were using hand grinders, and there was an incident where a drum exploded, resulted in 1 student being killed and 4 students being injured. Eric Layton was 18 years old when he died. He was described by classmates as being popular and caring, a fantastic athlete who was close to his little sister. When we look at the contributing factors of this case, very preventable. Yeah, greetings to Ottawa, from Ottawa, Richard. When we look at the causes and contributing factors of this incident, this involved both containment as well as a flammable liquid. The drums were washed out using an engine degreaser product, which was a flammable solvent, and the drums were then closed, which then allowed the flammable vapors to accumulate in the drum. And any time that we get containment, we also have potential for explosion. One of the interesting things about the previous case, again, containment leads to explosion. We're going to talk a little bit about fires in a couple of minutes. In this case, it was a combination of containment, flammable vapors, as well as hot work. hot work being the grinder, and it led to, again, a devastating death. The OCSB, the Ottawa Catholic School Board, was fined $275,000. There were lawsuits, obviously, by parents. I got filed against both the board and the teacher, and an 18-year-old young man, again, with his life ahead of him, lost his life. The third case study, of course, that we can't forget to talk about is Eastway Tank. Eastway Tank resulted in 6 killed, 1 injured. This was a situation where it was a manufacturer making oil and, water and like tanker trucks. And they were wet testing, pumping equipment in the fuel of a tanker truck that they had manufactured. Part of the final assembly process and the final quality assurance involves this testing. And the incident involved a gasoline air vapor explosion. And then there was a second explosion after that first explosion that then collapsed the building. The causes and contributing factors of this incident included the fact that combustible diesel fuel that's typically used for testing because it's combustible, not flammable, was in fact contaminated with flammable gasoline, which led to vapors being present at a level above the lower explosive limit. We also had various ignition sources that were present. There was hot work being performed in the area, but there's also potential for static. There's electrical. There's a lot of different ignition sources involved. And what's even more challenging when I look from a safety side is that this workplace had both a history of minor fires and smaller explosions, but they didn't change their work practices despite the fact that they had, in fact, had previous incidents with a loss, which was really surprising. It was one of those things that you need to look at and you go, is this, if we've had one fire and it's small, could this happen again? And we want to think about that with every type of incident, whether it's a slip, trip, fall, a cut. If you've had an incident happen, the chances of it happening again are very high. And it doesn't necessarily mean that the next time is going to be a low acuity incident. It could be a multiple fatality. Eastway ended up pleading guilty to 2 charges. They were fined $600,000 plus that 25% victim surcharge. The owner pleaded guilty to a charge and was fined $80,000 plus, again, a 25% victim surcharge. And the 6 individuals that were killed were Rick Bastian, Etienne Miabala, Kayla Ferguson, Matt Kearney, along with 2 others. And I always like to include names. Why do I like to include names? Because we cannot forget that every single one of these fatalities is someone's loved one. There's Danny Beal as well. Every one of these is a person, and every one of these deaths was preventable. So what are we going to be digging into as we dig into understanding fire? Ultimately, we're going to be digging into, for those of you who have taken certification or literally any other program with me or probably anyone else around here, we're going to be digging into the RACE process. We're going to talk about how to recognize fire and flame risks. We're going to learn more about assessing that level of risk, the data and information that's available to you and what to do with it, what it means. We're going to talk about how we control fire risks of flammable liquids, and then we're going to last talk about evaluation. So let's first talk about, we'll talk about these various risks, identify, gather information, assess, make a plan, make sure your plan works. Let's talk about understanding fire first. So what is a fire? A fire is a combination of fuel, oxygen, doesn't have to be oxygen, could also be another reductive agent. I picked the little cloud because most of the time it's atmospheric oxygen, but it doesn't always have to be. Ultimately, you're looking for something that has chemically reductive power. And when we talk about oxidants, not all of them contain oxygen. Interesting. You've got to have some sort of, ultimately you need to have fuel, something that will allow this to oxidize, an oxidant. You've got to have some sort of ignition source, whether that might be heat, flame, spark. We'll talk about a lot of those. And what does the fighting cartoon characters ultimately mean? The fighting cartoon characters represents a sustained, self-sustained chemical reaction. And you've got to have all of those. It's called the fire tetrahedron, but you've got to have all of those for an active self-sustained fire to occur. Now, I mentioned that explosion takes the elements of a fire and adds containment as that factor. Where you have, again, those four things, you've got fuel, typically with mixture dispersion. You've got some sort of reductive power, so an oxidant. You've got an ignition source of some kind. And you've got the sustained chemical reaction, and then that happens in a contained space. We get containment of the pressure that's being created through this chemical process. And when that happens and the containment, the pressure exceeds the ability for the container to maintain its structural integrity, you get an explosive energy wave as the container fails. That's ultimately what an explosion is. And these two things, fire and explosion, are tied together. Now, contrast that, of course, with fire. If you have no containment, you're going to get the fire piece, but you're not going to get the kablamo piece. So what are some of the most common flammable and combustible liquids? I would love for you to hop into the chat and tell me which flammable and combustible liquids your organization is working with. You know, some of the more common ones that I see in workplaces are things like aerosols, paints and coatings, paint thinners, turpentine. Gasoline is everywhere, but also acetone. I see alcohols. People forget that beverage alcohol is in fact incredibly flammable. They forget that rubbing alcohol, hand sanitizer is a flammable. It's a flammable liquid. Hand sanitizer and like the gel that you find in a Sterno can, obviously they're not the same alcohol. Like Body Safe, methanol, not Body Safe. So the actual chemical composition is a little bit different, but the difference between the Sterno can and your hand sanitizer is actually not spectacularly different in terms of like big picture thinking. We also have, of course, solvent degreasers, which are really common. And between flammable and combustible, you may also have combustible liquids that you're working with. So let's see some of the ones that are dropping in the chat. Acids, sodium bicarb, chlorine, isopropyl, aerosols, paints, coatings, adhesives. Adhesives are a big one, absolutely. Glues often are solvent-based. We grind our giant drives machinery of static dissipated footwear. Excellent. We're already starting to think about controls, paints and coatings. I'm not going to get too much into spray booths here today, but they do fall into our realm of Regulation 851, Section 7. Hand sanitizers, solvents. I mean, I could do a whole session just on spray booths, to be honest with you. Yeah, we're powder coating, including metallics. Okay, acetone, aerosols, fuels, brake cleaners. Oh, there's acetic acid, definitely. People forget that's also flammable. Heptane, lots of aerosols, isopropanol. Yeah, lots. Will we cover static dissipated footwear? I'm not going to go into a lot of detail about it. Like, this is not a session where I'm going to help you choose your footwear specifically. But one of the things I would always encourage you to do once you discover a need is to go and look at what the standards say, to go and ensure that what you are purchasing, what you're procuring, in fact, does meet the standards that apply. Now, we talked a little bit about flammables. What about combustibles? And we'll talk about the difference in a couple of minutes. Coffee whitener, combustible. Cooking oils, you heat it, it'll burn. Lubricants, cutting oils, diesel fuel, ethylene glycol. Again, you heat it, that'll burn. Even linseed and wood oils, if you add some heat, these things will burn. Is it better to store acetic acid in a flammables cabinet or in an acid cabinet? Ooh, that's a really good question. One of the things you may want to consider is having a cabinet for your acid flammables. We also want to think about compatibility big picture. So what else is in that cabinet? If it's a flammables cabinet, it just has acetic acid, I'm not too worried about it. If you have other things they could react with, I don't like storing products with things that are that they are incompatible with. If you are going to do that, you want to do secondary containment. One thing to know about acetic acid, though, is it is combustible rather than flammable. So I tend to lean toward putting it in the acid cabinet rather than in the flammable liquids cabinet. You could alternatively put it into a combustible liquids cabinet. Those are red instead of yellow. I hope that answers your question, Bertha. Yeah, I always think, and really do think about compatibility. That's ultimately one of the big questions. You've got flammability risk, you've got compatibility risks, and you want to manage both. There are also cabinets that will do acid and flammable. So therefore, your purchasing needs. So let's talk about recognizing ignition sources. Before I go and show these on the screen, give me some ignition sources in the chat. Tell me what you think. What are you're like, oh, I can think of some. Ignition sources dropping into the chat. We already talked about one extensively. Non-intrinsic equipment. Absolutely. We're going to talk a little bit about that. Static. Yeah, that's the one that we talked about. A big one that we talked about. What about others? Yep. Sparks. Heat guns, hot plates, yes, hot surfaces of all varieties. Apparently mobile devices, yes, mobile devices. Static for sure, unsafe behaviors, cell phones, there are lots. And there are so many tools with sparks, electric arcs, fans, motors, we think about vacuum pumps, I think about hand tools. There's heat, there's, improper venting. If you don't have we'll talk about whether or not you need to vent your flammable liquid storage cabinets in a few minutes. It is hands down the number one question I get. Yeah, any non-ferrous tools. So you could end up with end up with sparks. You want to choose your tools wisely. Vehicles are another. They both have hot surfaces and ignition sources. Even like that little spark plug that makes this thing work also could like kablamo your facility. So and when we look at the oil patch in particular, I did some looking in some research that was done around flammable liquid fires in Alberta, and they found that like a shocking, I think it was about 25% of all of their fires were actually started by a vehicle. Anything electrical, plugs, switches, lights, breaker panels, if it is electrically powered, batteries, whether it's battery powered or not, there's so much electrical that can be an ignition risk. Static discharge. And we talked a little bit about static within the liquid. We've talked about static discharge if it's something that's not properly bonded or grounded. We'll talk about that. We've got our hot surfaces. And when we think about hot surfaces, sometimes we think about our process equipment, but we forget that our building is heated, or that we have a hot water heater, or that we have a space heater, or that we don't think about ventilation equipment in the form of air conditioners either, because people picture an air conditioner and they're like, oh, it's making it colder, so therefore it's not a flame risk, but that's not true at all. Also, many of the propellants or the refrigerants are incredibly flammable. One of the spotlights that I want to put in terms of a big picture of your ignition source risk is static discharge. So electrical charging of materials through either physical contact, separation, and it creates this positive negative electrical charge that's formed by the process. That's ultimately what static is all about. And when liquids are filtered, you're getting static just from pushing it through the filter. When it's sprayed, you're getting static as it's blown through those little tiny holes. When you're pumping, it's actually generating static just from going through the pump. If it's being mixed, you can get static actually just from the movement within the container. Flow through pipes is another. It's one of the reasons why any piping system needs to be bonded and grounded if you're dealing with flammable liquids. This type of internal static, one of the really hard parts about this is internal static. If it is a non-polar product like we talked about, it is not well eliminated through bonding and grounding. So there is an additional level of risk. And one of the other hard parts of it, static, is that non-conductive containers, plastic, can't bond or ground that. Glass, can't bond or ground that at all. So your ability to dissipate static in a safe way that's actually internal static of the liquid is compromised depending on the types of containers you have. And we'll talk about containers as well. So this is not just like rub carpet on feet, touch container. It can actually happen within the liquid. Can you install a grounding rod? You can. If it's a non-polar product, it's better than nothing, just to be really clear. You definitely can. Be mindful. Often glass containers are used for things that are either corrosive, but they're also frequently used for things that are high purity. So if you're dealing with something like HPLC, that's a high performance liquid chromatography solvent, or a gas chromatography solvent that is extremely high purity, as soon as you go and stick your grounding rod in there, you probably just destroyed a $1,000 bottle of solvent. So not ideal situation. Another important thing to know about the grounding rod is, while it is better than nothing, again, if this is a non-conductive liquid, it's not going to conduct that static particularly well to the rod. So there are some very much like phys chem properties around the product that can lead to some of these issues. So let's talk a little bit about reading the safety data sheet, some of the things to look for. We want to look in section 2. This is where we're going to get information about our signal word. If you see the word danger, it's really dangerous. That's worse than warning. We also want to read those hazard statements. And as you're training your staff, product by product, for every product they use, I want you to go through section 2 with them. This is the most important information for them to have, because I can look at a symbol on a bottle, but it doesn't actually give me the big picture of exactly why that product has that symbol. Section 2 tells you exactly why, and it also includes precautionary statements about how to handle or use the product appropriately. We are also looking at section 3, composition and ingredients. I'm always amazed when I read the ingredients on products. Folks are like, oh, I had no idea this was flammable. I go, well, it has a flame symbol on it, but also it's 50% toluene. So like, you didn't know that was flammable. Okay. How effective would you consider static guns in flammable liquids? Again, if you're dealing with something that's non-polar, you're dealing with a phys chem problem that I don't think really, like, you're fighting the physics. And what is the number one rule of the world? The laws of physics apply to us all. Is it okay to ground only the table on which flammable liquids are sitting on? We dispense 1 gallon containers to plastic bottles. No. Yeah, no. I would not bond just the table. Does the ISTS identify polar versus nonpolar? It doesn't, and I kind of wish it did. And there's a range of polarities, but one of the things that you want to look for is actually to do some digging. One of my favorite sources for that information is on, if it's still in operation, the NIST Chem book. I don't know, maybe in the anti-science push from the United States, they got rid of it, but I can go look for the NIST Chem book. It's a favorite of mine. Murphy's Law. Oh God. Yeah, if it can go wrong, it probably will go wrong. It's really interesting. Yeah, how do we bond? How do we ground? I'll show you some diagrams on that in a few minutes. And it also depends on exactly what you're doing and if it's combustible versus if it's flammable. But I wouldn't just bond the table, because the table isn't the container. If you bond, let's say that you ground the table and then you bond the container to the table, that's actually totally reasonable. What you're ultimately trying to do is to dissipate the static discharge to Earth. And so long as it can get there, but if you take like a table and then it has rubber feet, even if the table is metal, if it's not grounded to anything, those rubber feet, now it's like sitting in its own little isolated universe, which is also not good. And don't just rely on it sitting on the floor. You really have to ground it to something specifically for that. Other things to look at, firefighting measures, so that you have the right fire extinguishers, so that you are prepared to, if you have a fire situation. We want to make sure that we have the right media. We also understand what's not the right media. There's some media that actually can make fires worse. Water being a really common one with flammable liquids. Cough, cough. Um, There's also special PPE that may be required for firefighters. That's all in the safety data sheet. I also always look for hazardous combustion products because if I do end up in a fire situation, how dangerous is the atmosphere? How dangerous is what's being produced? If it is super dangerous, that is something I will want to know. Another spotlight that I want to put on ignition sources is hot work. So what is hot work? It's any activity that involves open flames or other heat sources. It can be sparks, it can be flame producing equipment, and there are so many different types. There's soldering, there's plumbing, you could be using a cutting torch, you could be doing grinding. If you are engaging in brazing, all of these types of things have potential to generate heat or sparks, and there is a very high risk with hot work. So we'll talk a little bit about hot work programs as we get into the administrative controls piece of this. When I look at the example that I gave earlier of that workplace that had like a dozen fires before they called me and they said, well, I'm heating my like little knifey thing in a flame and then I'm wiping it with alcohol and I can't understand why my rags keep lighting on fire. And I said, well, you've got this combination of flammable liquid and you're engaging in hot work. Like these two things naturally lead to a fire. So ultimately we're going to need to do one of two things in order to make this safe. Either we need to eliminate the hot work part or we need to eliminate the flammable liquid part. We also look in SDS sections around physical and chemical properties. So what are we looking for? Oh, I probably will be re-recording this one for sure. Physical and chemical properties so far include the flash point. You'll find that in section 9. Lower and upper flammability limits, the auto ignition temperature, and your vapor pressure and density. I want to know how much vapor is being produced and does it go up or does it go down? We also want to look for stability and reactivity, including storage conditions to avoid. If this says you need to make sure that you keep this away from static, then you need a storage plan that's going to keep it in static-free space. If it says avoid shock, because this can this is something that is sensitive to shock, we want to avoid that. We also want to understand what it's incompatible with. So through our storage, we're storing things that are compatible together and are incompatibles away. Big picture hot tip, if it is an oxidizer, it goes away from your flammables. Of the things that I have seen that drive me up the wall are folks treating the yellow cabinet, the flammable liquid storage cabinet, as a chemicals cabinet. And what do they store in there? Everything, including bleach, including oxidizers, and then they wonder why you end up with a fire in the cabinet. I don't wonder. We also want to get a sense of whether there are hazardous decomposition products. Chemicals don't last forever. And as they decompose, they can actually produce, Daniel, yeah, and that's wrong. I just saw that hop in. Not sure what you were talking about there, but nothing combustible allowed in a cabinet. Oh, yeah, that is very wrong. No cardboard, no paintbrushes. It is specifically for flammable liquids. All the products in the same cabinet. Yeah, and I see it all the time, which drives me up the wall. Why do I want to know about hazardous decomposition products? Because our chemicals don't last forever. If I have something that maybe is not flammable or combustible now, but as it degrades, it actually becomes dangerous, I want to make sure that I'm using that product up or getting it off my site before it has turned into something else that is now, in fact, really flammable. So what are we going to do with all of this information? What is a flash point? A flash point is the lowest temperature at which a material will form a vapor in the air that will briefly ignite, or flash, when it's exposed to ignition source. There are a bunch of different ways that folks calculate these. I'm not getting into that. That's not what you're doing here today. The most important thing to know about flash point is it gives you an indication of when you're reaching the danger zone. Ultimately, low flash points are higher risk. So the little diagram on the side, low numbers are bad, high numbers are better. That's ultimately what you're looking for a flashpoint. And what's the difference between flammable and combustible? Ultimately, it's all driven by flashpoint. If something has a flashpoint that's higher than 93.3, it's not even combustible. If it is something that is between 93 and 37.8, it's combustible. And if it's below 37.8, we would consider it to be flammable. Again, as the flashpoint goes up, the risk goes down. As the flashpoint goes down, the risk goes up. There's also the auto ignition temperature, which you'll often see in your safety data sheet. This is the lowest temperature at which the material will self-ignite, even though there's no ignition source present. So if you think about all of those deep fryer fires that people have in their homes, what's ultimately going on is especially if you've got an electric stove, I have a gas stove, so like higher level of risk there. If you've got an overflow, because you have an ignition source present. But with an electric stove, it's not an open flame. You still have the heat source. You still have an ignition source. But I think it's really important to mention that if I take my canola oil and I heat it up and up and up and up and up, and it reaches above 500 and some odd degrees, I've got to look. I don't remember the auto ignition temperature of canola oil off the top of my head. The reality is that this will light on fire just because it's too hot. That's auto ignition. And again, the lower the auto ignition temperature, the higher the risk. And we never, ever, ever want to heat our liquid above the auto ignition temperature. Also, by the way, if you're cooking, check on the smoke point of your oil. Keep your oil below your smoke point. Not only does it just smoke up your house, it's also not very good for you once you've denatured a lot of that oil. We also want to understand vapor pressure and density. And when we're looking, what is a vapor? Ultimately, it's the gas phase of a material that's typically solid or liquid at room temperature. If I'm pumping gas, most of that's going into my car as a liquid, but I can smell, and just because you can't smell it doesn't mean it's not there. But I'm smelling that gas, and that would be the vapor. That would be the liquid fraction of this that is evaporating as I'm dispensing it. The vapor pressure, though, is the measure of the tendency of this material to change into a gaseous or vapor state. So vapor pressure, the higher the vapor pressure, the more vapor is being produced. And we also want to look for our density in relation to air. If it is something that is less than 1, it's going up. If it's something that's higher than 1, it's going down. And if it's at 1, that means it's fully mixable with air. It doesn't rise or fall. Why is it so important to know this? Because I want to be sure, for instance, if I'm working with something that has a vapor pressure that's higher than 1, to really be sure that I've got great ventilation, because this can creep along the ground. There's also the upper and lower flammability limits, and this is the space in which a fire can occur. If you have vapors in your space that are at a level below the lower flammability limit, you don't have enough fuel for this to flash off on you. If you have a level that is so high that it's above the upper flammability limit, you don't even have enough oxygen, you have too much fuel to be able to have this burn. So ultimately, what we're trying to achieve with things like ventilation, and often we're talking here about gases that are produced by these flammable liquids, these vapors, our goal is to keep our level below the lower flammability limit. When we look at internal responsibility big picture, what does the OHSA say? The employer has their set of duties. They have to ensure that they're establishing safe work procedures, that they're providing the right equipment, information, competent supervision. They have to acquaint workers and those in authority over workers with all of the information about handling and storage and use and disposal and transport of things like chemical, biological, physical agents, devices. They also have to take every precaution reasonable. And when we look at the charges that were laid against Eastway, every precaution reasonable was, in fact, one of the contraventions of the OHSA that was the basis of a charge. Supervisors, of course, have their own role. They have to communicate hazards. They have to enforce the use of policies and procedures, be sure that folks are using or wearing the devices, following the work practices, and workers have their role too as well. They have to advise their employers of incidents that happen, hazards that they find. They have to follow the procedures. They have to work in a healthy and safe way. And all of this comes back to the fire piece as well. Ultimately, employers need to set everyone up for success. Supervisors need to communicate and enforce, and workers really need to follow those protocols to the letter. When we look at what the Industrial Establishment Regulation 851 says about fire, one of the things that we need to talk about is pre-start health and safety reviews. And item table 1 talks about flammable liquids specifically. Either of the following applies to flammable liquids. You need to have a pre-start health and safety review with some exceptions. More than 235 liters of flammable liquids are located in a building or room, or flammable liquids are dispensed in a building, room, or area. That's not and, it is in fact an or. So either. The exceptions are no more than 235 liters of flammable liquids are stored per adequate cabinet. There are fewer than 3 cabinets, or 3 or fewer cabinets containing flammable liquids in a group of cabinets, and the cabinets are at least 30 meters apart. If you meet those, then no, you don't need a pre-start health and safety review. Fire code breaks flammables down even more. We are talking about the fire code in just a second. If auto ignition decomposition limits in section 9 are so important, why is this data not mandatory on safety data sheets? It's frustrating, not determined. One of the interesting things, this is where I often go to the NIST Chem book. Sometimes it's because they, if it's not a single component, if it's like a mixture, they may not have actually done the testing. There are others where it's not applicable. So if it's not a flammable or combustible liquid, the information may not be available. But Catherine, it is a pain point for me too. I find it really frustrating, and if I can't get the information, define dispensed, transfer to one container to another. Yep, Michael, you hit the nail on the head. If you're transferring it from one container to another, this is a high risk activity. That's part of the reason why dispensing is such a, and when we look at that first case study, it was dispensing that led to that fatality. It is the NIST, so National Institute of Science and Technology, NIST Chem book. It's free. I used it to find physical properties on individual ingredients for what I was working with in the chem world. Extensively. It's almost like having a handbook of chemistry and physics, which is like this thick, and I do have one in my basement, that is on your phone. So highly recommend. It's really technical, so if you're looking for something that is approachable for an average worker, 0 to 10 do not recommend, but if you are someone who wants the little details, down to like the 84th percentile, you can get that. It's very, very, very detailed. I love it, but not everybody loves this chem. All right, so ultimately, if you meet this requirement, and just to be very clear, factories only, but if you meet the definition of a factory under the Occupational Health and Safety Act, and you meet any of these, meet the requirements in this table item, and you do not meet the exceptions in the table item where all of the following are met, you actually need a pre-start health and safety review on your flammable liquids. There is also a section, a table item about spray booths. I'm not going to get too much into that. But again, if it is a spray booth that is designed and installed and constructed in accordance with applicable standards, you don't need a pre-start health and safety review. If you're doing something weird with your spray booth, you do. But if you've got a spray booth, which is one of the ways that we often control both worker exposure as well as flame risk, it also does fall into the pre-start health and safety review element. So highly recommend. And I'm happy to send you the Ministry's guide to the pre-start health and safety reviews. They have a much more detailed explanatory document. Highly recommend. The info on the slide is stated that Ontario Fire Code, if pass PSR, does that mean that we are still in violation of the fire code? Here's where things get interesting. if you're getting a PSR from a qualified engineer that specializes in flammable liquid management, I would like to believe that that engineer would have used the fire code as part of their assessment. And if they did not, oh, hey, Mike, if they did not, I have hard follow-up questions for the competency of your engineer. And Mike, feel free to chime in on that one if you have thoughts. Mike is also one of our fantastic specialized consultants here at WSPS. So what does the Industrial Establishment Regulation say? It says that in section 22, there's a whole section, there are two sections, 22 and 23, that talk about flammable liquids. We're not required, oh, Mike's on mute, but he agreed with what Tova said. Excellent. We're not, if you meet the criteria for fire code, you also need a fire plan. Yes, absolutely. Yeah, and we're going to talk a little bit about fire plans as well. So where not required for immediate use, flammable liquids shall be in sealed containers located outdoors and remote from any means of egress. But if they're in a building, not used, they could be in a building not used for any other purpose, or they could be in a room that's either separated from the rest of the building with partitions, equipped with a drain connected to a dry sump, and having natural ventilation to the outdoors by upper and lower wall gravity louvers. So that is one of the options for you. You either need to have outdoors, in a building not used for any other purpose, in a specially designed room, where it's, again, not used for immediate use. If they're in open containers, that's super dangerous, or having a flash point below 22.8 of a boiling point and a boiling point below 37.8, they have to comply with Clause 1B. They also have to be stored in facilities that have no potential for source of ignition. When located, be located in a room equipped with explosion venting and spark-resistant floor. 22 also talks about that maximum 235 liters of flammable liquids may be stored in sealed containers of not more than 23 liters each, or be in a metal cabinet of double-walled construction with a 3-point door latch, a tight door seal, and it has to have a door sill that is at least 50 millimeters above the floor. The customers that I've talked to most recently, they were actually receiving orders on their flammable liquid storage cabinet because it was 25 years old and it didn't meet current applicable standards. So if you have one of these really old flammable liquid storage cabinets where the doors, where like the cabinet is double walled, but the doors are only single walled, you may actually receive an order that requires you to get a new container. What if the room has an electrical outlet with closed containers? If you're not dispensing, and you're not creating vapors, it's not so much of a big deal. If you are dispensing or creating vapors, that electrical outlet could potentially be an ignition source for you if, again, you end up with vapors that reach that lower explosive limit. And where we have subsection 4, an area where flammable liquids are dispensed. Woo! It has to have mechanical ventilation from floor level to the outdoors at a rate of 18 meters cubed per hour per meter cubed of floor area, and containers and dispensing equipment have to be bonded and grounded. So if you think about bonding and grounding and you're like, ooh, is this just like Tova saying that we should do this because? No, it's actually right in the Industrial Establishment Regulations, also in the fire code. Fire prevention, portable containers. So section 23 talks about portable containers, and they have these nice ones that have a spring-loaded cap and a flame arrestor. It's self-closing. That is the expectation for portable containers, okay? And many of the portable containers do not, in fact, have this. So if you're using a safety can, open little spring-loaded cap, flame arrestor on the inside, you're good to go. If you have something that doesn't meet this requirement, it's time to start discovering the magical world of portable containers that meet this requirement. Can you bond and ground plastic containers? No. No, it's not possible. It's plastic. Metal containers can be bonded and grounded. Fire code also classifies liquids differently, and they set different expectations depending on whether it's a class 1A, a class 1B, a class 1C. This is why looking at your flash point is so important. Often this will also be in your safety data sheet. Combustible liquids shall be class 2 or class 3. And again, we're looking at if it's got a flash point below 22.8, it is a class 1A. Boiling point and a boiling point below 37.8. Class 1B has a flash point below 22.8 and a boiling point above 37.8. Again, all in Celsius. Class 1C, flash point at or above 22.8, but and below 37. So as we get higher up to class 1A, the level of risk goes up and the requirements, in fact, go up, along with the containers often get smaller. Jerry cans of gasoline. Yeah, you can't grab those either. Plastic. In with the plastic. As you are dispensing it at your fuel station, take it out of your vehicle, put it on the ground, be sure that you are, to the best of your ability, touching the container. Be ginger with it. We also want to make sure that we're not using our cell phone, our car is not running. Those are some of the things that we do to prevent jerry cans from lighting on fire. I also am still a little bit amazed that we have the click to keep dispensing. I'm surprised that those are still around for gas at a gas station, but I know that they do have a safety system on them. We talked a little bit about class 2, class 3. Class 2, these have a flash point above 37.8, so now we're talking more about our combustibles. Class 3A have a flash point above 60, but below 93.3, at which point something is considered to not be combustible. I'm not going to dig too much into the details of the fire code because this could be a 7-day course or it could be an entire university lecture series over an entire semester. Suffice it to say, the two areas that I really want you to go and look, and then also go and look at occupancies and being sure that you have a good fire plan. If you need any of these, flammable and combustible liquids, that part contains information on fire safety plans, spills, ventilation, container storage, storage tanks, bonding and grounding, piping, distilleries, and labs. And part 5 has hot surface applications, spraying. It also covers special processes for automotive undercoating, floor finishing, bowling alleys of all things, and dry cleaning. It also talks about dip tanks and hot work, which we will also talk about. Now, again, not going to go into a lot of detail, but I think it's also important to remember that looking at the fire code is not the end of the conversation either. It actually references close to more than a dozen different applicable standards from ASTM, ASME, the American National Standards Institute, or ANSI, there's CSA, there's Canadian General Standards Board, there's the Compressed Gas Association, Underwriters Labs of Canada, which is different, the National Fire Protection Association, National Research Council of Canada, which is actually where we get the Canadian National Fire Code from, which differs from the Ontario Fire Code. It's all research-based. Transport Canada and Natural Resources Canada also has some standards, as well as the Office of the Ontario Fire Marshal. So all of these are referenced in the fire code itself. So you may hit on something and say, okay, well, if we're going to get a flammable liquid storage cabinet, we're going to get one, and it has to meet one of these applicable standards. And then you would go look as you go make their purchase to be sure that it meets that applicable standard. So let's talk about how we control fire risks. Ultimately, what are we trying to do? We're trying to break the chain. And we do this by either, removing the fuel, removing the oxygen, removing the flame sources, removing the ability for the spontaneous, this reaction, this self-perpetuating chemical reaction to occur. And when we do that, ultimately, we are then removing our fire. That is the goal. And a fire will cease when you take one or more of these things away because you don't have the physics to make it work. We first want to ask, can we eliminate our fuel sources? And we can do that by really thinking critically about what we're buying. Why are we still using solvents? Could we be using something water-based? Water doesn't burn. Could we be using something we could be using a water-based adhesive. Maybe we could be using an epoxy adhesive instead of something that has solvents to it. We could be using a battery tool rather than fuel-powered. That does not get rid of it as an ignition source, to be clear, but If it means you no longer have to have gasoline in your workplace, maybe that's a bit of a win. You could try non-solvent-based cleaning methods entirely. You could move to sandblasting, or you could move to sanding or wiping with, water instead of using some of our degreasers that are in fact solvent-based. We could also try to eliminate as much as possible collateral damage. This means look at your circle in which you are working and saying, hey, could this burn? And if you can, in fact, eliminate or move these, if you do have a very small fire that starts, it doesn't spread all the stuff around you. When I talk about collateral damage, I'm talking about cardboard. I'm talking about, gloves. I'm talking about oily rags. I'm talking about the surfaces of your walls. People forget that some kinds of paint are flammable. And as soon as you go and get a fire going, now you have that oil paint up the wall that's now burning on the wall. In an ideal world, you'd be working in an area where you have you're kind of doing your dispensing in an area where there's absolutely nothing else around you. Your walls are made of unpainted cinder block. You clean up your spills immediately, and then you get those rags or whatever out and deal with them appropriately. Oily rags can, and then outdoor storage, to be sure that you are minimizing the ability for a fire to spread, ultimately. Could we eliminate oxidizers? It's impossible to eliminate atmospheric oxygen in ordinary work environments, just to be really clear. But we could eliminate the use of oxidizing chemicals, or really try to separate as much as possible anytime that we're using things like nitric acid or ozone or permanganates or, chlorines, hypochlorites, all of these things that have the potential to add chemical power. We want to not be using those or storing them anywhere near our flammables. We want to eliminate ignition sources. Some folks mentioned, is there a hierarchy for fire code? If you are a distillery with a laboratory, which one would take priority? So what I would suggest is that you treat those as two separate spaces. You meet the distillery portion of the fire code in your distillery facilities, and you meet the laboratory portion in your laboratory facilities. By the way, if you're interested, if I get enough people interested, I'm always happy to run Hidden Hazards of your QA lab again. The last time I tried to run it, I think we only had a handful of people, but hit me up if you're like, I want to know all about the hidden hazards of my quality assurance lab. They are jaw-dropping. Feel free to email me at tova.larson@wsps.ca if you're like, I really want to see that session. Can you Facebook? I took a note. Sure. We were talking, though, a little bit about eliminating our ignition sources, so intrinsically safe tools. If you're bringing something in, be sure that you are thinking intrinsically safe. You're welcome. All right, so intrinsically safe, we want to think about everything electrical. We're talking gas detectors, water heaters. We're talking about vacuum pumps. We're talking about prime movers. We're talking about spark-proof tools. We're talking about spark-proof hand tools. Ventilation fans, all things to think about. If you're buying it, it's powered by a battery or electric, intrinsically safe is the way to go. We also then want to think about eliminating ignition sources in the form of hot work. Don't heat your flammable and combustible liquids. That just drives more vapor and adds another source of fire. We want to think about moving your smoking area as far away from your flammables as possible. Obviously, we don't smoke in workplaces these days, but some folks forget this. Do not apply force or impact or friction to flammables, as some of them are, in fact, sensitive to shock, and that can lead to a fire. We also want to ban hot work in areas where flammable liquids are being stored, dispensed, or used. And if we have to do hot work in that area, we want to get the flammables out of the area, eliminate them, move them to another area, allow the hot work to take place, and then move them back once it is safe. We can also use substitution by choosing products that perhaps mix less with air. You could choose combustible instead of flammable, so the risk is down, it's not eliminated. But we could also choose either brush-on or roll-on products instead of a spray. You get less mixing with air. You aren't necessarily dealing with flammable propellant problems. And mixing with air is one of those things that just adds to the risk. It just kind of blows it everywhere, and now you have this perfect cloud of flammable stuff. How to safely transport drums? Sounds like forklifts and cranes are not suitable. provided that they're closed, they're completely suitable. Absolutely, a drum clamp is a great way to do that. I would not be moving any drum that wasn't closed. My answer for you. We also want to think about choosing our flammable liquid storage cabinets wisely. They do have limits to the amount that they can hold in terms of liters. We want to be sure that we're keeping that below the amount that is in our, keeping the amount in our cabinet below the level that that the cabinet establishes as its limit. Oh, that was really complicated. Don't overload them. There we go. Containers and bottles have to be closed. You don't put open containers in here. You shouldn't have open containers anyway. If you're not using it, close it. Those fans are so good. They self-close. Inspect your shelf clips. Of all the things that I see fail, the shelf clips in these are very high on my list of things that just like collapse. We also want to locate these away from emergency exits. You want to be running away from the cabinet, not by the cabinet. And true or false, we need to vent these. What do you think? Good answers. False. They do not need to be vented. And venting is, provided that all your containers are closed, which they are supposed to be. How do you prevent cabinet stink, by the way, for things that you're storing long term? Just grab a roll of electrical tape and just tape around that neck. It'll prevent 80%, 90% of what's evaporating out of your bottles from ending up in your cabinet. They do not need to be vented outside. And if you are venting them, all of that needs to be made of like cast iron, flame-proof pipe, and it's complicated and messy. I typically recommend people don't vent them. And under section 4.1.7.2, subsection 2, ventilation referred to around these cabinets need not be provided for the storage of class 1 liquids if storage consists only of closed containers and no dispensing operations are performed inside the cabinet. There we go. Desiccant filter. Don't need it. Eliminate the oxygen source. You don't even really need to do that, to be honest with you. And by the way, these are designed it's not to contain a fire in the event that one occurs in the cabinet. It's actually to protect the containers if a fire does occur. Do they need to be grounded? Yes, I would ground them. Yeah, I would ground them. I would not, but you don't have to vent them. What was that section? 4.1.7.2. That's where you find in the fire code the bit about venting. All right, let's move on. By the way, do your staff actually put stuff back and close the containers every single time? Because you may not. We also can move into an engineered atmosphere space. That's another engineering control, or use inert gas flushing. I don't see this that much. I did it in the lab a lot. I worked with a lot of pyrophorics, but it's not practical. Like, I would never recommend this to like the little furniture shop down the road. It's probably not necessary for them. Assess your risk. It is one of the ways to manage this. Especially if you're in research spaces where I see it most often, or in process safety where you are dealing with very large quantities, and then they'll often use these gases to try to eliminate, as someone said, to eliminate the oxygen, that atmospheric oxygen. Container materials, pros and cons. We talked a lot about plastic already. For metal containers, there's a 230 liter max. These are bondable and groundable though, so that is good. You've got to like scrape the paint off though. It's got to be bare metal to bare metal. Glass, there's a limit of 470 milliliters for a class 1A, all the way up to 3.8 liters for a class 2 or class 3. Glass is often used for high purity or corrosives. It of course is breakable. It's also not bondable or groundable, so that's why there are limits to the amount you can have in these. Again, designed to keep fires, if they do occur, small. Plastic containers, they also do have some limits on the levels. You find these in NFPA 30, by the way. And it's not easily breakable, which is great, but it is dissolvable depending on what you put in them. It's also not groundable, or so that is a bit of a risk. But it isn't breakable, so it's a little better as a choice if you can get away with it. But again, metal is your best choice, always, because it's bondable and grindable. One container alert that I want to put out there is around aerosols, because sometimes they contain non-combustible product, but then you add a propellant and that's flammable, and then you have new problems. The container, of course, is under pressure and it can be ruptured if it's heated, but also if the propellant catches fire, it can then flash back inside the container and then it blows. So we are so surrounded by these aerosol containers. I'm looking at you, WD-40, people have them all the time, and they don't think anything of them. But then they don't store them appropriately, or, they just leave them out on the bench top, and they are just as risky. We also want to think about our safety containers, flame arrestor, self-closing lid. There's a variety of materials. I always choose metal wherever I can. There are also these little pumps for soaking rags if you're doing that. That is the safety can for that. Whaley rags, that little red trash can made of metal, is not regular garbage. It has to be emptied every single night. And the problem is that as things evaporate, it can actually cause heating that can cause these oily rags to light on fire. The still leftover paint lubricants in small quantity do not really deal with any other flammable liquids. You still need a flammable liquid storage cabinet. They make them this big. Like, if you want one that's the size of a microwave oven, you can get one. So yes, small quantity. Do you guys have the red trash cans, by the way? We're heading into noon, so I'm going to move forward. If you do, in fact, have these oily rags trash cans, do you actually empty them nightly? You may not. If you do, Carolyn, you're my superstar. You're like, no, I don't have them, or no, we don't empty them nightly. They say on them they have to be emptied nightly. They didn't put that label on there for no reason. What is bonding and grounding? Grounding is attaching this system to earth. Bonding is electrically connecting two containers together, ultimately. And it has to be metal on metal. Where should they be put? Outside in metal. Yeah, absolutely. Preferably away from your building. Again, ask, if this lit on fire, how bad would this dumpster fire be? And if the answer is bad, then move the dumpster further away. If it's just a dumpster burning in an open field, there's a very limited amount of damage that can realistically do. Why do companies allow recycling of oily rags if they need to be removed nightly? It's a good question, and I would love to tell you I have an answer to that, but I do not. That is pretty surprising. How many feet or meters away from the building? I don't think it's specified in the regs, but I can try digging that up for you, a little bit more information on that. Juliana, feel free to send me an email, and I will see if I can find an answer for you. I'm always happy to dig up answers for folks. I mentioned this before. You can only bond or ground metal containers. Get some sandpaper, metal on metal. And there's specific like branding clamps and wires and things like that for this. Ventilation. Things like extraction arms, canopy hoods, natural ventilation if you're outdoors. We don't want to do this in like an alcove or like just a garage with the door open. When I talk outside, I'm talking 360 degrees or like one side of the building. That's it. So you've got lots of ventilation, but ventilation is really about two things. It's about protecting from fire, yes, but it's also about protecting the worker, using it at the source. If you can't go at the source, we always want to go at the path wherever possible. As we're thinking about ventilation, we want intrinsically safe fan motors. It has to be sufficient to draw those heavier than air vapors. Meet NFPA 91, which is specified in the fire code. It needs an audible alarm, so if it's not working, you will know to stop what you're doing. And you have to maintain these. Don't just like set it and forget it. And we talk about those vapors, like they can flash back. They can creep along the ground, find your water heater, and then go kablamo. Knowledge is ultimately power. We want to ensure that our staff have the information they need to keep themselves safe. And we talked about that early on, about labels and safety data sheets and WHMIS, and some of those requirements around training. I also would encourage you to develop safe operating procedures for all of your flammable liquids and combustible liquids. You need to have written plans for how you're going to manage this, so you have something to train your staff to and hold them accountable to. We want to have a great evacuation plan. Be sure that you have your muster points designated. You have the ability to check in and be sure that you know who was in the building, so you can tell who didn't get out if that in fact occurs. Put yellow hash tape in those emergency exit zones, so it's like the no stuff zone. I would also encourage you to have regular fire drills and to ensure that your emergency plan does meet the fire code in accordance with the requirements around flammable liquids. And do have visual and auditory alarms, especially if you have people wearing hearing protection. If they can't hear the fire alarm, that is scary as heck. Safe work practices. Do have a written procedure for decanting that includes bonding and grounding. How are you going to manage non-conductive containers? Do have very clear storage requirements, and then again, hold people accountable. Don't allow that housekeeping to be an issue. You also need to have a plan for spills. It's right in the fire code. Choose the right adsorbents. Be sure that you have spark-proof shovels, that you're not using metal, that we're disposing of this loaded adsorbent in a flame-proof container, and of course that we're disposing of this outside. What about bonding the person doing the decanting? Provided the containers are that, like, you shouldn't be. I usually try to touch metal before I go and decant or dispense, but unless they're like, I don't see a lot where it's the person is the problem. I usually see where the liquid or the container is the problem. Question about hot work. You have a hot work program. What is a hot work program? Do require a permit for all hot work. Eliminate your flammables from that area. Assess before you go ahead with that hot work. Have your fire extinguisher immediately present. Have a fire watch, an active human people eyes fire watch after the work is complete for a specified period of time. That way you ensure that fire is not occurring. And be sure that you're asking your contractors about their hot work programs, because it's usually contractors that don't have them and that you don't have a hot work program, that nobody assesses this, and then bad stuff happens. Excellent. Yeah. Catherine said, for us, permits are required in all of the areas except designated weld shop. And the designated weld shop, I assume, also has a risk assessment that goes welding here, flammable liquids over there. How do we account for the contractors and visitors in a fire safety plan? I would encourage you to always have people sign in, sign out. That sign in book is how you ensure that you know exactly who is in that facility at any given time. Workplace violence, security, it's all good. Last is clothing and equipment. One of the most devastating cases, it is 12 o'clock, just to be really clear. If you have to jump off, I have 2 more slides left. My apologies. Clothing and equipment. You need a clothing policy. No polyester, no fleece, cotton, wool. Cashmere is expensive, but it's really nice. It cannot be a synthetic. And that includes underneath your lab coats. Nomex or flame-proof uniforms, absolutely critical. One of the tragic, they're all tragic. One that really spoke to me as a chemist was the death of Sherry Sanji at the University of California, Berkeley. She was working with pyrophorics. She was poorly, if at all, trained. Her supervisor was not in any way bought into safety. And she died after working with a pyrophoric substance that lit on fire. It caught her on fire, and her polyester sweater melted to her skin. 100% cotton or wool underneath your coveralls. Do not allow any synthetics at all. I would also encourage you to use leather pull-on dissipating footwear. Why pull-on? I don't want any metal grommets that are on our shoes either. And do be really clear with your staff about why they can't wear polyester. And if you require them to wear cotton, provide it for them. And that's the uniform. Even better, provide something flame-proof like Nomex. Why cotton? Wool doesn't burn all that well. Cotton, when it burns, it doesn't stick to the skin, it falls off. It will ash. Absolutely devastating. Last week, assess. Think about how you're managing this. I would love to know, what was your favorite takeaway or aha from today's session? Drop that into the chat as we're heading off into our noon hour today. Yeah. What was your favorite takeaway that you're like, oh, I'm so glad that you found value in this. Can you go back a slide? Yes, absolutely. Or, was it to evaluate? Ultimately, what you're looking for is to see that the risk has gone down. And when we think about bringing the risk down, have we reduced the amount? Have we of flammable liquids so the fires are smaller? Have we managed to eliminate some of those flame sources? Have we managed to reduce the impact of the fire? When we think about Nomex, if a fire does occur, or the cotton, we're reducing impact on the worker. Ultimately, we're looking for reduction in risk. That's how you know that you're making progress. I hope this was really valuable. Yeah, no worries if you have to jet. I'm also here to answer questions. I know there were a couple in the chat. Some were super technical, and I'm happy to go dig up an answer for you. I don't always know things right off the top of my head, but I'm happy to go and dig up an answer for you. Yeah, I'll send you an email with a question. Yeah, you can also, yeah, please do, John. If you have a very specific technical question, feel free to go ahead and send me an email, tova.larson@wsps.ca. And if I don't know the answer, I will go and find someone who does know the answer. That's what my job is. So, however, the safety associations can be of value. We do have some occupational hygiene toolkits that we're happy to send you. I think these are going to be sent out by Camille, so you'll be getting these. We've got some women's related stuff. We've got some hygiene related stuff. We've got some great designated substance tools you can use. And we also have some pre-recorded safety connections. I'll be sure Camille sends you the links to those as well. So if you want to know about the hygiene campaigns or how to prepare or even how to do a designated substance assessment yourself, we've got you on that. Yeah, my email's up in the chat. I will write my email as many times as I need to, tova.larson@wsps.ca.